Hello fellow Unreal Engine artists, designers and developers. In today's tutorial we'll be looking at converting spline meshes into static meshes, when you need to do it for performance, and the best ways to consolidate structures for instancing and reuse in your level. Let's get straight into it. Now, before we even get into showing how to convert your spline meshes, we're faced with the thorny issue of should we convert them? In the developer community, this is known as premature optimization, and if not needed, this leads to slower development as it becomes harder to change your designs on the fly. If we convert our meshes too early, every time we make a change, we have to convert again and again. For example, let's look at this sample scene where I've got 64 copies of my spline actor. Admittedly, it's not too complicated. I might be convinced to convert these to static meshes for performance at this point in time. But let's actually look at the current profile of our GPU. So go down to the console command and type profile GPU. And up comes a visualizer showing you all of the events on the GPU and how much time they're taking up. So if I order these by duration, you can see that the number one here is seen. We can break that down further. So you can see that the things that are taking up the time at the moment are diffuse, indirect and ambient occlusion. So lumen. So if we didn't need lumen, we could switch that off. Lumen reflections. I don't really need reflections in this scene, so I could switch that off. Let's have a look in post-processing. Temporal super resolution is taking up 0.72 milliseconds. So I could switch that off and go back to a different anti-aliasing method, although I might prefer the visual fidelity of that. And things like bloom. I don't need bloom in this scene, and that's taking up admittedly a small amount, but they're all taking up more than the mesh editing at the moment, or mesh rendering I should say. So you can see here, there's the base pass editor primitives. Somewhere in here is going to be the mesh processing as well. But my point is that there are other things to concern yourself with before you even worry about the mesh rendering. And as we'll see later on, it makes it much harder for us if we do change our meshes into static meshes earlier, because we can't edit them as efficiently. So you always want to be able to develop in a quick and iterative fashion when you're at the early stage of development. So let's assume that you've been through these processes and you've got a lot more spline meshes in your level, and you decide that you do need to convert them. And then there will come a time when you do need to. I'll explain why later on. Let's talk about how you convert those now. So let's first talk about how not to convert a spline mesh into a static mesh. And you may have tried this and scratched your head and thought, why doesn't this work? So if I select my spline wall here and I go to the actor menu, you can see here, fourth one down, convert to static mesh. And this is the one you may think, well, that's obviously the one I need to select. So if you select it and decide where you're going to store your mesh, so let's put it in the generated content and let's call it SM room. Save, and it says successfully converted to mesh. So it sounds good, but when we go back here and we drag it in, where's our SM room here, you can see that it's nothing like the original. And what convert to static mesh does is just simply convert any mesh references in here into a static mesh. So it's converted a wall segment and a pillar segment, and maybe even a door segment if that was being referenced as well, into one mesh. So it's clearly what we don't want. But fortunately, there is a method that does work successfully, so I'll show you that now. So the correct way to do it is to select our spline wall actor and again go to the actor menu, but instead of choosing this convert here, go down to merge actors. And choose the merge option. And when you click on that, it will ask where it wants to save the static mesh. So we'll call it SM room, save it, And this time, if we look at it in the thumbnail, it looks as though it is a correct representation. So now we can drag this in and put it next to it, and you can see that this is the original spline wall, and this is now a single static mesh. So the benefits of doing this are that it will reduce the complexity of the draw calls on the graphics card. So I go down to the console command, and if I do stat FPS, that will show me frames per second. So you can see I've got 120 frames per second at the moment. In fact, probably more than that, probably been capped. And I can also do stat unit in the console command, and that shows me how each frame is being divided up between the CPU and GPU. And you notice one of the elements here that they're always saying to try and keep down for graphics performance is the draw calls, number of draw calls. So at the moment you can see that it's hovering around about the 3,500 amount. So let's take all of our, we just converted this spline wall into a static mesh. Let's replace all of these spline meshes with the static mesh equivalent. So over here in my outliner, I'll select, I've got 64 of them. I will select the first one and go down and select the 64th one. So I'm not going to select the original. I don't want to change that. And I can just right click here in the outliner and say replace selected actor with. Make sure you've got your static mesh selected in the browser that you've just created, and I can replace it. And what you'll notice is that visually it's the same, but the draw calls have reduced by about, I would say, 80%. So they've come down from 3,500 draw calls to 700. And that's, if you think about that, that's because the spline mesh here consisted of at least 5 or more individual components, and now it's been rendered down into one single spline mesh component. So it's reduced the draw calls. But this is what I'm saying about performance. I was getting 120 frames per second even before I did that, because although it is better from a draw call perspective, it wasn't the key performance bottleneck in my solution. So now you know how to do the basic conversions. What do we do if we want to change things? So if I wanted to change this, now originally I had copies of all of this, but now if I want to make a change, let's say something simple like I will add a new spline point here, move that in. Maybe I'll add a door at the back of the wall as well. So let's do a door in the middle there, maybe a couple of windows as well. And actually let's make it a, actually I want the window around the door. Maybe let's make it squarer wall, squarer rooms as well. Again, it doesn't really matter. I'm just showing you that I'm changing it. So let's change that. So I'm doing Shift T on my spline points to make them into tangents. And in fact, let's delete that point there because I want it to be a square room. Okay, so I've changed that, and now I want to reflect it in all of the other copies. So all I need to do is go back up to the actor, merge. Let's select my room. Do I want to replace it? Yep. And you see straight away that all of those other elements are replaced here. So it's quite effective in terms of making changes. This original one I may not want to be in my level, and probably in a later video when we look at geometry scripts, I'll look at how Lyra allows you to swap in and out individual components. So even if I'm working on this one here, I can right click and say swap it for the spline version, work on it, and then swap it back out again. So I'll show you how that works in a future video. Let's look at how you convert these meshes if you want them to be nanite. At the moment, these are just regular old static meshes, and there's no level of detail on these at all. So although they're pretty simple, so they probably don't need it. What happens though if this was a more complicated set of meshes with a more detail and we wanted to convert it into nanite? So converting our spline meshes to nanite is almost as simple as the previous method. So we select our spline mesh or spline wall, we go to merge actor. This time make sure you go into the merge settings, and you'll see, in fact it tells you here all of the components it's going to be merging, just in case you want to see what was in the original spline wall. And then you have all these various settings. Now most of them you normally leave to their default, but if you come down to the nanite settings, you can decide whether to enable nanite or not. So if I click on enable nanite, and I can do merge actors, and I'll overwrite the room again that I just created. So superficially it doesn't look as though there's any difference in these static meshes that I've just created, but if I go into the nanite visualization view, you can see that these are now nanite. And if you take a look at these walls here, you can see at the moment, because we're a fair distance away, they're just represented by two triangles. Now this isn't a complicated mesh, but you can still see the effect. If we fly in closer, as we get close to the wall, it will start to subdivide into more detail. You particularly notice it on the door, where there's subdivisions on the vertical as well as the horizontal. So as I get close to the door over here, you can see it breaks down the detail. Now this is a flat plane, so you don't notice anything, but in buildings and other structures with very detailed geometry, this will be very useful for keeping the triangle count low in the distance until you get up close. So again, very straightforward to convert the static meshes into nanite. Now I said I would tell you why you might want to do this conversion, even if it's not a performance issue. So let's explore that now. Now I said earlier that you shouldn't always convert your spline meshes early, especially if you want to do editing of individual elements. So I've reverted back to spline meshes for all of these 64 rooms in my scene here, and I want to show you another reason why you might want to convert for convenience while you're in your editing and developing phase. Let me show you one of the issues of having these all as spline walls. Let's say all of these 64 spline rooms in my scene comprised a structure that I wanted to move and duplicate. Even just moving it, let's say I wanted to move it over to this side of the level. So if I select and try and move it, it's incredibly sluggish. I mean, you can't really see it on the screen, but I'm moving my mouse and it's responding about 2 or 3 seconds later. And if I wanted to duplicate this this set of rooms to somewhere else, I'd have exactly the same problem and have real difficulty in positioning it. So another reason for doing the conversion to static meshes is so that you can easily move group of elements around. So in the next section of the tutorial, we'll talk about different ways of grouping and consolidating your groups of meshes. So now I've established there's an issue with moving large groups of elements around in their original spline form. We need to replace them with the static meshes we've generated again. So just like we did in our first conversion option, we'll right click on all of our 64 rooms and replace these with the static mesh room. And now we have the static one here, albeit it was the last one I generated. Now I've generated like this. If I select all of these 64 together, let me just shift click in the outliner. Now moving them around is a breeze. So you can see they move around smoothly. And if I want to duplicate all of these elements here, then I could just do Alt and duplicate them. By the way, I never mentioned why it was probably so sluggish when you were moving the spline walls around. My belief is that because every time you're doing a move, it's running the construction scripts on all 64 of these spline walls. So that is quite a lot of calculation to be doing every time it moves position. Whereas with static meshes, there are no such calculations to be done. So you can see here that it's very smooth to move around. Now let's talk about grouping and the different ways you can consolidate these elements and the pros and cons of each approach. So let me just delete this copy here. Let's actually start off by regenerating this mesh here. So select it, actor, merge on our room, and that way we'll get our circular rooms back here. So the first method you can choose is just simple grouping. So if I select all of my rooms, and if you do, you can either right click and do group or Control G, and you see this green box appears around and they're now in a group. So what I can do now is if I wanted to, let's say I've clicked off this, if I click on this, it will select the group. If I wanted to move it, obviously I can move it as a group. If I wanted to duplicate it, I can hold Alt down and duplicate the group. So this is a nice simple way for quickly keeping elements together. The pros of this approach is it's obviously simple to group and ungroup. You can do Shift G to ungroup, and then you can change individuals again. Then you can select groups again, or select elements to group them together. The negative of this approach is that you have to ungroup to change individual elements. And the other issue with this, if I select this and say move it down here to create another duplicate, let's say I want to change something in one of these groups. I've changed this group over here. If I delete something or if I move it around, these are completely disconnected from the original groups. So they all live as their own set of elements, which you might want, but that is the negative approach. If you had a template set of elements and if you changed anything in there, you wanted it reflected in the copy somewhere else. So let's now look at another approach for consolidating elements into a group and see if that has any more benefits. Now let's look at the concept of instancing. You can see that in our original spline actor, the spline wall system says self beside it. If you look at the static mesh actors, you can see that they have instance beside them. Now this is an actor instance, which is still pretty good. That's why our draw calls came down from 3,500 to 750. But you could have everything in a single blueprint with static mesh instances or instanced static mesh components. There are two types, and I'll explain later on what the two types mean and why those two types exist. So to convert a group into an instanced static mesh component, all you do is select all of the elements in the group. So let's select our 64 static meshes. Make sure not to select the spline wall here. And if we go back to our actor merge tool here, there's an option here for batch. And if you click on that, you'll notice that visually nothing's changed, but what's happened is it's made all of those original static meshes invisible, and it's created a new actor, if I can find up here, which consists of one instant static mesh component. And this actor contains all 64 rooms as instances. And you notice the draw calls has come down a bit more. So it was 750 and the draw calls is now down to about 640. So again, if you had a huge amount of elements on the level, then this would make a big difference. So again, when performance is needed, this is another thing that can further increase it. Now, can we still access individual elements? Yes, we can. So you didn't used to be able to do this. This used to be a real problem with instant static mesh components. You wouldn't be able to select them individually, but I'm not sure when they changed that, but you can come in and you can still select individual elements. You can move them. You can't do, there are certain things you can't do. So if you look, when I'm selecting the item, I've got location, rotation and scale, but I can't change the mesh. Because this is an instance component, it's an instance of the same mesh. So I can't change the mesh and have different meshes in this group, but I can do all the usual things like move, rotate, and scale. I can even duplicate elements. So if I wanted to duplicate something here, I could hold Alt and duplicate it, and I can also delete elements as well. And so that's it's pretty flexible. If I take an instanced static mesh component and I copy it, get it here. In fact, let's rename it to group of rooms. So if I select it and say I wanted to duplicate it, so I'll come up here, hold Alt down and duplicate the whole thing, and again it's nice and responsive, static meshes. If I change something individually, so say I take this one here and I delete it, it's only changing it in this one. So there are two issues with this. I mean, first of all, it's slightly better performance, but like the grouping problem, we can't reflect changes back into the original. So each of these groups acts independently of the other, which again you might want, but if you don't want that, we need to find another solution. And as I said, the second thing is that you can't change the meshes at all in here. So they all have to be the same mesh, albeit you can have slightly different variations of transformation. So the other last thing that's a bit of a problem here is it's quite messy to restore the originals. So that's why it kept these originals here, because if you didn't have these here and you wanted to expand this back into the original elements, there'd be no way of doing it. So the only way of doing it at the moment is if we delete the group of rooms. So if we delete that one and we delete the copy we made, the group of rooms too, we don't have anything there unless we come here and we make these visible again. So you can see we can recreate all those. So I'll go through and make all of these visible again. There is one other gotcha with restoring these. You'll see the problem later on and we'll show you how to fix it. So we've tried grouping, we've tried instancing. They're okay, but we want something where you can copy a group of elements, still have the ease of editing them, but be able to change meshes within the individual elements and to have changes in the original group reflected in the copy groups. Is there a solution for that? Yes, there is, and it's called pack level actors. So this final option I'm going to show you for consolidating your meshes into groups of meshes is, as I said, called packed level actors. And I've restored all the 64 meshes here. If I right click on them, you'll see that there is a level menu here with two sub menus. The first one says create level instance, and you would use this if you didn't have static meshes. So if you had a group of actors which also included blueprints and other elements that actually have some interactability, then you would use this. But create pack level actor, which is a bit of a strange name really, all it does is it creates a level with all of the static meshes contained within it. So click on that, and the first thing it'll do is it'll come up with a dialog. You pretty much will always want to leave this as it is. External actors means there's going to be one file per mesh, and then the pivot type and the pivot actor you wouldn't normally change. So click OK on this, and it's going to ask you to save this as a map. So I'm going to call this a collection of rooms, and click save. And the next thing it will generate for you is a blueprint for the pack level actor. So it's called BPP, and the name I gave to the map, BPP, a collection of rooms. And click on save. And what you'll notice in the level here is that our 64 meshes have been replaced by a single item here called a collection of rooms, that blueprint. And so now what we can do is we can still move things around. We can use Alt just like before to duplicate elements. Let's do that. And everything's just as smooth as before. But there are some big differences with this. The first thing is that you can still edit individual elements. It might not be obvious at first how to do it, but it is very easy. If you click on the group, if you don't have to, you might think you have to go into the level it's created and edit things there, but you don't have to do that. All you do is right click and say edit a collection of rooms, and you can see that it grays out any elements that aren't in that level. And now what we can do is we can move things around just like before. We can rotate items, scale them, but each of these items is an individual static mesh, so you can change meshes and collisions and all sorts of granular elements here. So say for example we wanted to replace this mesh here with, I don't know, a rock, so I'll select it here. Let's change that to a rock, and let's scale it up 5 times so I can see it, and let's duplicate that a few times. So let me delete these ones, take this one, use the Alt key, and let's create some copies of that. So I've got different meshes in here and various different transformations as well. Now if I now click escape and it asks me if I want to save them, yes I do. Notice that this group over here has changed to reflect this. So this is one of the big differences. Because this references a level and we're changing the sub-level effectively that this is stored in, those changes get reflected. So this is the perfect solution for where you want to create a group of elements that form a structure, and if you change that original group or structure, it gets reflected wherever you've copied it on the map. So I can't really think of a situation where this is not better than the instant static mesh option, because I think this has everything that has and more. But if you know of a reason why you would want to use instant static meshes on their own and not pack level actors, then let me know in the comments and I'll correct my advice if necessary. Now another really clever thing about the pack level actors is they do all of the instant static mesh and hierarchical instant static mesh stuff for you. So let me show you that. If I select this element here, so that's the blueprint. If you select it here and you have a look, let me just bring this up so you can see this a bit clearer. Can you see how the collection of rooms here has 2 hierarchical instant static meshes? And so the first one is the group of rocks. So sorry, this one is a group of rocks here. So it's got the rock and it's got 4 instances, and this one here is the rooms, and it's got the rooms and the other 60 instances here. So the pack level actor automatically creates the groups of instant static meshes, which is the performant way of doing it. And I said I'd talk briefly about what the difference is between the instance static mesh and the hierarchical. Hierarchical ones take into account LOD. So if you have meshes which have different levels of detail, the hierarchical instant static mesh will respect that and make the detail lower as you go further into the distance. With NANITE, that's not an issue. So just to prove that point, if I take my original element here and if I do a actor merge again, let's look at the settings. I think it was, and set it to NANITE here. So now we're going to convert this into a NANITE version. So do our merge, we'll overwrite the room here. Okay, so again, visually no difference, but these are now NANITE meshes rather than ordinary static meshes. If I go in here and I do an edit, so just like I did before, so let's do any change really. Let's just make another rock here. Press escape, save. Now, if we look at this collection of rooms again, can you see that the NANITE rooms are now instant static meshes, not hierarchical? And that's because there's no need for hierarchical meshes for NANITE because there are no levels of detail. So as I said, pack level actors very cleverly convert the meshes to the correct ISM or HISM type in there. So we've been doing this. Let's duplicate this a couple more times and let's go into play and see what it actually looks like in game. So let me take this one here and duplicate it again. So we're going to have 256 meshes on the screen. Let's grab this one over here and let's go down somewhere here and go into play mode. And immediately you look around saying, hey, I can't see anything. All I can see is the original there. And do you remember earlier I said that there would be a little gotcha with the meshes that we reverted from creating our instanced static mesh component? Well, I'll show you what the problem is, just in case this catches you out as well. I can see it when I'm in the editor, but I can't see it in the game. And that's because when we converted our group of meshes into the using the actor batch command into this instant static mesh component, you remember it hid all of our meshes. Well, it also set them to hidden in game as well. So what we need to do is we just need to make sure that all those meshes are not hidden in the game. So let's just select this. Let's go to the mesh, so edit. So let's just select all of these, and if you select for hidden, should be able to do this here. So I've just unselected the pivot element, and you can see actor hidden in game is set to true. So if I uncheck that, that should make them visible in the game. So let's come out of here and save that change. And now let's go into play. And you can see that all our elements are there. And let's just do a quick frame rate here. So 120 frames per second. Yeah, you see, we're getting a great frame rate here now. I did do this with the Spline wall versions as well, and it was lower. It was about 109, 110, but it was still eminently playable. So my takeaway from this video is, don't convert your spline walls until you have to, because if you want to do individual changes to the meshes, you can do them in place. As I said, I'll show you the Lyra version of doing components, because that is a really clever way of swapping in and out the original splines or geometry scripts. But largely speaking, you tend not to want to convert too early. However, if you are creating big groups of structures and you want to duplicate them around the level, then you saw how sluggish it was when I moved big groups of spline walls around. So in that case, just for convenience and for smoothness of editing, convert them, and then you can move them around, and you can always go back to the original and change it if you need to. So I hope you found today's tutorial useful. In the next selection of videos, we're going to be exploring geometry scripts. So we'll start off with a simple example in the next video or two of how to create structures using geometry scripts, and then we'll start to go into more complex structures, putting those elements together. So stay subscribed, and I will see you in the next one. Bye for now.